Hi, my name is Ryan Rivera, and this is Unit 2 Case Connections video presentation for biochemistry. I'm going to start with Case 3, which was the 5-year-old boy that was brought into his pediatrician's office by his mother. Reported he was a sickly infant and displayed some drowsiness and persistent thirst with frequent urination. The question posed some blood samples that were taken of the insulin measurements right before and 1 hour after a meal, and the results of the loading test indicated, glucose loading test, that the serum insulin on the child's baseline blood sample was 0.8, and the control should have been, at that point, before eating, 6 with a deviance of plus or minus 2. So given that the patient's serum levels of insulin were 0.8, which is extremely low, not even one whole number as compared to where it should be between 4 and 8. That was extremely low level of insulin before a meal, and then after a meal, when it should have been rising higher to facilitate the uptake of glucose in the blood, it actually only went to 5, and it should have been between 40 with a deviance of plus or minus 11, so it should have been between basically 30 and 50, but it was only at 5, again indicating that the presence of food and glucose in the blood did not stimulate the release of insulin. So obviously this is an instance where the pancreas is not secreting insulin or nearly enough insulin, which seems like type 1 diabetes. And given some of the symptoms, the biochemical basis for some of the symptoms that the child displayed as related to type 1 diabetes could be that his drowsiness was related to the fact that insulin was not released in the presence of glucose in the blood, which then cytoplasmic signaling pathway was not initiated by the insulin on the cell, and the metabolic pathway of glucose uptake into the cell was not mediated because of the lack of insulin, or not enough insulin. So the energy to enter the metabolic pathway to produce energy was never initiated. So that could contribute to some of the drowsiness and lack of energy and coordination that was reported. And as far as the persistent thirst and frequent urination, that's a typical sign of diabetes 1 and 2. But given the patient's age, I would say it's more likely than not likely that it's type 1. And the reason that the persistent thirst and frequent urination happens is that as the glucose is not taken into a cell, it accumulates in the blood, and it has a high affinity for fluid. So as the glucose accumulates in the blood, the kidneys try to filter it out, and it takes the fluid along with it. It's excreted in the urine, causing excess thirst and excessive thirst, and or dehydration that causes excess thirst, which is another symptom that we saw. So the other question was, what would you predict the patient's fasted glucose levels to be given his current condition? So in a fasted state, somebody with diabetes would display a higher than normal level of glucose in the blood because there's a lack of insulin to take it up. So I would predict that his fasted blood glucose would be higher or above the normal range of fasted blood sugar. And then 2 regulatory enzymes that could be activated with diabetes Type 1 diabetes, I'm speaking to particularly because there's a lack of insulin. And when there's a lack of insulin, low insulin levels can cause or activate glycogen phosphorylase, which is an intermediate in breaking down glycogen into glucose when insulin levels are low, to try and take the glucose and convert it back in. Take the glycogen that's in storage and convert it back into glucose and put it into the blood to balance out the levels again. But glycogen phosphorylase is activated when insulin levels are low. So like I was saying, once glycogen phosphorylase is activated in the presence of low insulin, glucose 6-phosphate is hydrolyzed by glucose 6-phosphatase, and then glucose then can be released. So that's why glycogen phosphorylase is activated in low insulin environments. And then the other enzyme that's activated by presence of low insulin is intracellular hormone sensitive lipase. And basically what this does is it signals to the adipose tissue to release the glycerol, the fatty acids, because there is a lack of free energy in glucose in the blood and or glycogen. And then the body can then break down the fatty acids to be used as an energy source in the liver, heart, and skeletal muscles, because there's an absence of the preferred metabolic fuel, which is obviously the glycogen. Case 4 is about the 2-month-old female baby with jittery spells an hour after breastfeeding, and the mother. A couple key things I saw in this case was the mother says the child has not had anything to eat other than breast milk, and the child has recently began sleeping for more than 2 hours, which was a big sign because that's when they're first beginning to fast for longer. And the child, something else significant, the child had hypoglycemia and elevated lactate levels when epinephrine was administered, which is another big thing. The liver was enlarged, and blood glucose levels increased after breastfeeding, but she was able to maintain those blood glucose levels within normal range during a little fasting period. So some of the answers I don't think it is hereditary fructose intolerance. Obviously, that could cause vomiting by the ingestion of it. The baby was not reported the child had vomiting, so I'm going to roll that one out automatically. But that is just intolerance to fructose. I don't think that correlates with the symptoms. Galactosemia, being unable to fully break down simple sugar galactose, which is half of lactose, the sugar found in milk. Again, if it was a problem with ingesting it, there probably would be vomiting. And also there's some more severe symptoms here with convulsions and lethargy, which were not displayed either. So I'm going to say that that's ruled out. And then I do think that it is glycogen storage disease. And that is a condition in which people with lack an enzyme needed to properly break down the glycogen. And what happens is the glycogen can accumulate in the liver, and it can cause the liver to enlarge. And one of the mechanisms that can cause it, there were several different types, but one of the mechanisms that can cause that to one of the mechanisms that happens can actually produce excess lactic acid. change the pH of the blood. Obviously, during the Cori cycle, is not able to proceed past the step where glucose 6-phosphate is made, and right before glucose 6-phosphate, the previous steps were the production of pyruvic acid and lactic acid. So the end result is a buildup of lactic acid and pyruvic acid, because the metabolic process cannot proceed into further into glycolysis, and so it ends there, and then those build up in the blood ultimately, which is why when they administered the epinephrine, which is basically a stimulant, just like if you were to go out running or exercise or use your muscles, it would tell your body, hey, we need energy, go and break down the glycogen, use it as glucose, use it to make energy. Well, it couldn't progress past that. I mean, the epinephrine, I don't want to say that, artificially activated that process. So when they gave the epinephrine and it activated the process of starting to pull that and make, pull the glycogen and turn it back into glucose, put it in the blood, it couldn't get past lactate. So the lactate built up. And the other big thing was this condition normally starts when the baby starts to go into prolonged fasting periods, like when it starts to sleep longer, which the baby did just start doing, which was sleeping longer, which showed that when the levels rose when it ate, it was unable to hold those levels while it was fasting because it was sleeping longer. And again, the Cori cycle, this is where glucose 6-phosphate is, but as you can see, pyruvic acid, lactic acid right before it, if it's unable to proceed, that's the end result. So the symptoms that were related to the symptoms the child displayed, obviously the jittery spells could have been due to not feeling comfortable, low blood sugar the baby had, enlarged liver the baby had, and too much acid in the blood the baby did have. And then I don't think it's glucose 6-phosphate dehydrogenase deficiency, because that affects red blood cells, causes hemolytic episodes, dark urine, jaundice, pallor, and fever. Some of the things the baby doesn't have. It can cause an enlarged liver or abdomen pain, which I guess the baby could have had because it had an enlarged liver, but I don't think the symptoms of glycogen storage disease fit the symptoms displayed by the child. Anyways, that's 13 minutes. It's a little over. Did it as quick as I could. Sorry if I was talking fast.